Hello students, welcome to Dr. Shourabh sir classes. As you know that we are solving the UPSC mathematics optional paper of 2021, right? So it is a paper 1 of for mathematics. So those who have this mathematics as optional in their UPSC civil serviceman examination, so that will be this video will be helpful for them. And one thing is that, so for those who have this looking for this solutions and here and there but not getting the exact answer, so but you have come here to the right platform. Okay, so don't worry. So this we will solve this one by one. So let us take this question of 3a part 1. Okay, so here you have this: if u is equal to x square plus y square and v equal to x square minus y square, where x equal to r cos theta and y equal to r sin theta, we have to find this del of u v del r theta, right? So we can write this as this del u v del xy equal to this del of xy del r theta. Now you do this, so what you will find, this it will be, so this is multiplication, right? This is multiplication. So here it is del u del x del u del y, we have del v del x del v del y multiplied by, this is del x del r del x del theta, and we have this del y del r del y del theta, right? So now do this. So we have del u del x, so it is quite simple now. So we have to do this, so it will come as 2x 2y, and the del v del x is 2x minus 2y, right? And if you multiply this side, it will be simply cos theta minus r sin theta, and it will be simply sin theta and r cos theta. Okay. So multiplying this on this side, it will be minus 4xy we have. So on the left hand side, it is minus 4xy, minus of 4xy, and it will be r of cos square theta, right? Minus and minus will be plus sin square theta into r, right? So we have this minus of 8xy r. That's all. Now x, put the value of x over here. So this is minus 8 as it is. So that is minus 8. Now put the value of x, that is r cos theta, and it is r sin theta multiplied by r. So we have the final answer as minus 8 r cube cos theta sin theta, right? So this is one of the form, and simply we can write this as, so it is minus of 4 r cube sin 2 theta, right? So that will be the answer of this particular derivative, this partial derivative. So it is minus 4 r cube sin 2 theta. So here I have shown all the steps explicitly, as you can see. So this is a quite easy problem, right? So okay, let's move to the next one, that is 3a part 2. So this question is saying that if the integral 0 to x ft dt is equal to x plus integral x to 1 t ft dt, then you have to find the value of f1. So that is the question given. So it's a pretty, so what is the given? First write it in this manner. So 0 to x ft dt, right? So which is equal to x plus integral x to 1 t ft dt, right? So if we do the derivative on both sides, so that is the form, that's d dx of 0 to x ft dt, right? And similarly on this right hand side, it is x plus integral as it is given t of ft dt. Okay, now we have to apply the Leibniz rule. Okay, so then, okay, we can do a little bit. So that is the Leibniz rule. If we apply this, so on the left hand side we will have, so that will be simply 0 plus fx minus 0. On the right hand side it will be ddx, it will be 1 plus 0 plus 0 minus of x fx. Now here you can see that that is simplified into fx 1 minus x fx. So put this x fx on the right hand side, so we have 1 plus x fx equal to 1, right? So from here you can find this f of x is nothing but 1 by 1 plus x, this 1 upon 1 by 1 plus x. So we have to find the f of 1. So now putting the value, this simple, so we have this f1 equal to 1 by 1 plus 1, that is equal to half. So our answer for this question is f of 1 equal to half. That is the answer for 3a part 2. Okay, so next go to this part 3. So we have solved this 3a part 2. Now move to the part 3. So it is saying that express this integral, integral a to b x minus a to the power m b minus x to the power n dx in terms of beta function, right? So what we have to do, let us take that, put x is equal to a plus b minus a z. So what will be dx? Dx equal to b minus a dz, right? Now if we put x equal to a, then z is equal to 0, and if we put x equal to b, then z is equal to 1. So now whatever the integral is given over here, so that is integral a to b x minus a to the power m b minus x to the power n dx, right? So totally transform replace the x with the particular value. So we have, in the first instance, it will be integral will be from 0 to 1, right? And it will be b minus a z to the power m, and it will be b minus a minus of b minus a z to the power n b minus a dz, right? So if we simplify it further, it will be 0 to 1, that is fine. B minus a to the power m z to the power m, and then it will be b minus a to the power n 1 minus z to the power n b minus a dz. Okay, so from here we can do one thing. So here you can see that b minus a, it is m, n and 1. So b minus n to the power m plus n plus 1, right? And the integral will be 0 to 1 z to the power m 1 minus z to the power whole to the power n dz, right? So we can write it in the terms of the beta function. So in the beta function it will be b minus a to the power m plus n plus 1, right? And beta function it will be, so beta of m plus 1 comma n plus 1. So the answer will be integral a to b x minus a to the power m b minus x to the power n dx. So it will be equal to b minus a to the power m plus n plus 1, this function, the beta function b of m plus 1 comma n plus 1, if this m is greater than equal minus 1 and n is greater than equal to minus 1, right? So that will be the answer in terms of the beta function. So this solves our question 3a part 3. So we have the 3 parts to this question. So the next video we will solve the remaining parts of the question number 3.